is to go into Google Classroom, okay? And so on the home screen, you will see that I have posted, okay, new assignment, Properties of Compounds Lab. Okay, if you click on that, it will take you to this screen. Okay, so this is the screen from which you will do the work, okay, necessary for this lab report. In here, you will already see that there are 2 videos. All right, one is what we're going to do today, the pre-lab activities. Okay, and one is the observations video. If you're going to be here on Thursday, you don't need that. Okay, if you're not going to be here on Thursday, and that's just for those people who have told me already they're not going to be, okay, you're going to need to watch that video. All right, it is one of the things that came out of COVID. You couldn't be here to do labs, so we had to do the labs virtually, which meant I took my GoPro and filmed in 4K myself doing the lab. And you can get all the observations you need, okay, from that video if you're not here. Or maybe you do the lab and you just want to double check that you got the right results. It's not long, okay? It's like, it's 25 minutes, but you could scrub through probably parts of it, okay, and get what you need from it, okay? But that's, if you're going to be here on Thursday, you're probably not going to need that one, okay? Now, you might be asking yourself, well then, Coder, why do I need the one that's a video of what you're going to do today? That one, you're going to need to help you with this. Sometimes you miss what I say in class. That happens. I drop a big juicy hint about what exactly I'm looking for. Maybe I accidentally or not so accidentally give you an answer to something, and it gets recorded. It's always worthwhile to go back over that video while you're assembling your final lab report. Okay? And I would say while you're doing it so that it's concurrent. Otherwise, it's like do my lab report, watch the video, go back to the lab report. That's more work. That's working harder, not smarter. Okay? You want to work smarter. So what I always tell people to do is when you're kind of checking over your lab report or while you're putting it together, you just have the video playing. You're working on the design, but part of the video talking about the design is playing. You're writing down all the big juicy hints Coder gave you. Okay? Then you pause it and you finish up the design part. Okay? Then you hit play again and you're working on the hypothesis. And Coder's in your ear talking about the hypothesis and giving you hints about how to make it good. Okay? And then you pause it and finish up your hypothesis. Get the idea? Okay, because like on this first lab, I'm going to take a big spoon and feed you with it, okay, for this first one. You're going to get lots of big, juicy hints. I hear Mrs. Baxter coming right now. Okay. Okay, so that's the purpose of the recordings. They're just to help you out, okay? And if you ask anyone who's taken my class before, okay, if you want to do well, those are the things to watch, okay? Because, well, they'll tell you, I pretty much give you like big, giant, almost answer type hints, okay, and give you pretty clear expectations for what I'm looking for, all right? And it happens sometimes that you miss it in class. That's what those are useful for, okay? All right, so what we're going to be working out of today is the Google Doc, okay? So if you open up that Google Doc, you will see this, all right? You're going to be filling this in. All of your labs this semester are going to have a similar layout. Okay, I'll have the skeleton here. You've got to fill in the tissue. Okay, so everything is set up. Okay, you just have to tell me what was the problem. Okay, what's the manipulated variable and why and how. Okay, what's the responding variable? Why, how? What are the controlled variables? 3 of them. Why and how. Okay, and then your hypothesis. Okay, the materials are already done for you, so you don't have to do those, and you'll never have to do those in all of the labs. The materials will already be there. Okay, the procedure. This is the only lab where you have to write it, but I'm going to tell you basically all of the tests you're going to need to run, and you just have to put that in your own words. That'll be the bulk of the work today. Okay, and then tomorrow, or sorry, not tomorrow, on Thursday when we do the lab, you'll be filling in this chart with your observations. Okay, so not a bad idea maybe to print it because we won't have the Chromebooks on Thursday, or you can do it on your phone. Some people do that. They just open the Google Doc on their phone and they put in the observations as they go. That totally works too. Okay, so you'll be filling that in. And then you'll do your analysis. We can't do that until we have observations to analyze. And you'll fill in your conclusion and your evaluation. The class discussion you don't have to do. We talk about those when I hand back the lab and go through it with you. All right? Making sense? Okay. So what you guys will need to do today is follow along with me because I'm basically going to tell you how to do this part of the lab. Okay, I know that right now that looks like the shortest part of the lab, but it's actually the longest part of the lab. Okay, this part you do in the lab, and the other part is just figuring it out. Okay, all right. So the problem that we're investigating, and this has to be stated in your own words in the form of a question on your lab report, okay, is how could several unknown compounds be classified and identified? Okay, we're going to have a whole bunch of unidentified materials at the front of the lab, and you're going to have to classify them as ionic or molecular, and tell me what is A. Is A water, or is it sodium chloride, or whatever? All right, so you need to restate the problem in your own words in the form of a question, kind of like Jeopardy. Okay? Okay, the next step here, okay, and again, you're going to get some pretty big juicy hints here, is that we need to identify and explain, or for you, fill in, okay, the design part of the lab report. That is, we have to decide what is the manipulated variable, how is it being manipulated and why, what is the responding variable, how is it responding, why, and what are three controlled variables, that is things we are keeping the same so that they don't affect the experiment. How are we keeping them the same? How would they affect the experiment? Okay, that's what we're going to do next. It's a lot, but I'm going to help you out quite a bit today. And then as we go along, I'll wean you off of that, okay, and you'll be doing it on your own. All right, so the manipulated variable is the part of the experiment that the experimenter manipulates himself or herself. Okay, so in this lab, here's what we're doing. In this lab, we are going to have a battery of tests. Okay, and by a battery, I mean a collection or a series of tests, okay, that we're going to run on 11 different unknown compounds. Okay, those 11 compounds are going to be tested exactly the same way. All right, so I'm going to take substance A, and I'm going to run the tests on substance A. Then I'm going to take substance B, and I'm going to run the same tests on substance B. And then I'm going to take substance C, and I'm going to run the same tests on it. Okay? Every time I run the tests, I'm running them on a different unknown compound. And then I'm recording the results or the observations of those tests. Okay? Does that sort of make sense? All right? So what am I, given that description, as the experimenter, changing in this experiment?
The compounds that you use?
Exactly. Every time I'm using a different unknown compound. That makes it, or them, the manipulated variable. Okay? Now, each one of those unknown compounds has unique physical properties. Would you agree? Okay? Every compound has a unique set of physical properties. That might be why I'm manipulating. I need to find those properties out, don't I? That's how I'll identify it later. Agreed? Okay? So when I'm explaining my manipulated variable, okay, I'm going to say the manipulated variable is the unknown compounds. You can totally write that down. I just gave that away. Okay? The manipulated variable is the unknown compounds, or the unknown samples, if you want to call them that. We're manipulating them because they all have their own unique properties that, once discovered, could be used to identify them. If you put that in your own words, you've got your explanation for the manipulated variable. Each time a new compound is being tested, because they all have unique physical properties that will allow us to identify them. Okay? You got to put a little meat on that, but that's generally the explanation. for why the unknown compounds are the manipulated variable. Okay. Sorry, I'll give you another second. All right, so let me ask you this. I test compound A. I run all these tests that I'm going to run on it. Then I test compound B, same tests. Do they behave differently in the tests? Okay, so do the results of the tests change because I test something else? Okay, could we then say that the results of the test respond to what I'm testing? Would that make them then, the results I'm talking about, the responding variable? Are they different each time I test something else? Yes, they are. That means that they're responding to what I did. I tested something else. When I test something else, I get different data. Does that make sense? Okay, so I'm going to let you kind of explain that one through. I'll repeat it one more time in case you missed it. Okay? Each time I test a new substance, the results I get from the tests will be different. Okay? So that would mean then that the results of the tests are the responding variable. They change because something new is being tested and it's different. Okay? Okay. Every time I run the tests on a different compound, there are things that have to either be kept the same or done the same. Okay? These are our controlled variables. They are things that could affect the experiment, okay, and affect my results if I don't keep them controlled, hence the name controlled variables. All right? So there are two kinds of controlled variables. Conditional controlled variables, that has to do with the environment, okay, or sizes and things like that. Things that are kind of just around the experiment that could affect it. Okay? A really easy conditional or environmental controlled variable is temperature. Okay? Does temperature affect lots of things? Okay. One of the tests we're going to run in this experiment is solubility. Does temperature affect solubility? Then it's probably something we should control. Would you agree? Okay. So one of my controlled variables then is temperature. Okay? You explain to me how it's going to be controlled and why. I kind of already told you the why. Okay? So I'm going to really help you out with the temperature one. You can basically write down what I tell you here. Okay? Temperature is a controlled variable because it affects solubility. It's being controlled by performing the experiment in a climate-controlled laboratory where the temperature will not fluctuate more than 1 or 2 degrees during the experiment. Okay, this is how we identify and explain our controlled variables. We first say this is a controlled variable. Temperature is a controlled variable. Then we say how it could affect the experiment or why we're controlling it. Okay? We're controlling it because it could affect solubility. And solubility is one of the tests being run in this experiment. Okay? It's being controlled by making sure the lab stays the same temperature with a thermostat. Okay, so I explain why I have to control it, or what effect it would have on the experiment, and how I'm going to control it. You have to do that with all 3 controlled variables that you identify. Okay, now, I'm going to give you a little description of the experiment, and from this description, you should be able to glean the other 2 controlled variables in the experiment. Okay, so you're gonna have to listen carefully. Yesterday I showed you the depression plate that we're gonna perform the tests in. Okay? When we do this lab on Thursday, your instructions are going to be to put enough of the unknown compound in the depression to just cover the bottom of the dish. Every single compound, you want to put in just that much. Okay? You want to make sure that you just cover the bottom so that essentially we always have the same amount of all of the unknowns when we perform the tests. Everyone is going to use the samples that'll be at the front of the classroom. Okay, so all the samples are going to be shared by everyone. Okay, and when we're doing this lab, okay, especially when we do the solubility test, your instructions will be to add enough water to make the depression about 2/3 of the way full. Okay, so everyone is going to add water to the unknown sample until the dish is 2/3 of the way full. Then they'll stir and take the temperature, all of that stuff. Let's talk about the hypothesis. Right? Remember that the hypothesis contains these three words plus a bunch of other words. If, and, then. Every hypothesis has to have those three words in it. Right? The hypothesis talks about our premise, what we believe to be true or what we are working on. Okay? The and part describes how we're going to test that briefly, so the experiment. Okay? And the then part says what we're going to get as results and or what we're going to be able to do with them. Okay? So given those parameters, here's what we're trying to do, okay, and what we believe. We believe that all compounds have unique physical properties. Okay? That every one of those unknowns has unique physical properties. Okay? That's the premise we're working on. This experiment doesn't work if that's not true. Okay? So all compounds have unique physical properties. Okay? The tests we're going to run an experiment that basically tests their observable properties, things like color and stuff like that. Okay? Their solubility, the conductivity of their solutions, and their pH. Okay? Now you don't need to put all of those necessarily in there. Okay? Remember, the and part is going to briefly describe the experiment. Maybe in the experiment what we're trying to do is identify the important physical properties for the unknown compounds. Okay? Tests are being run to identify those physical properties. When that's done, what are we going to be able to do? What do you guys think? Once we've run the tests on all of those unknown compounds, and we have all of our observations, okay, we know that compounds E is a blue crystalline solid that is highly soluble in water, whose solution conducts electricity and has a pH of 6. Okay, what am I going to be able to do with that information? What do you think? I can analyze it, and what am I going to be able to use it to do? Will I be able to figure out which one of these things substance E is? Right? This is a list of the possible identities of the 11 unknown compounds on the front table. If I've got a list of the physical properties for each one of them, I should be able to match it up with that list, yes? That's the then part. That's what I'm going to be able to do. Okay? In the then part, you talk about what you're going to get, the physical properties of each compound, and what you're going to be able to do with it. Okay? So the if part has to do with this idea. Okay? That everything has unique physical properties. Okay? If that's not true, we can't get a list of properties for each one that would allow us to identify them. Okay? And, okay, okay, don't make your hypothesis exactly what I'm writing here, because it's not enough. I'm giving you a little bit of tip here. You have to embellish, maybe that's not the right word, enhance what I'm doing, okay? Then, okay, right? Those are the things that need to be included in your hypothesis. It's going to be a bit wordy. They always are. Your English teacher will probably not like what we write down for hypotheses. They would probably call them a run-on sentence. They'd probably be right. Okay? That's the nature of a hypothesis. They're a bit wordy. Okay. So what you and your group are working on for the remainder of class, about a half an hour, is you've got to write a procedure to follow to discover these tests. Now, you're not completely on your own here. I'm going to tell you what tests you need to run, right? But when we talked about what a procedure looks like, remember, it's got to be detailed and explicit so that someone with zero ability to do anything, like tie their own shoe, would be able to follow your instructions and do the lab. Okay? So we got to think about everything here. Like when you go in the lab, what's the first thing you should do? Put on safety goggles. Okay? That's part of your procedure. You're welcome. Okay? Go into the lab, put on safety goggles. Okay? Then tell them where the unknowns would be, where the equipment you're going to need is going to be. I'll tell you that right now. Okay? All the equipment, the conductivity tester, all that stuff is going to be on a cart in front of the classroom. Okay, so you and, it says your partner there, but it's going to be group. Okay, let's say groups of 4. Okay, we'll use the materials above to match the unknown samples with their identities. Okay, the design will include the charts you will use to record the results and the various tests you're going to perform. You should also include in your observations the observable physical properties of each unknown. There's your first test. Okay? The first test that a person needs to run in this lab is what we call the observable properties test. Okay? So when you're writing the procedure, one of the steps is going to be perform the observable properties test. Now, can you just leave it at that? I wouldn't. Okay? Because if I knew absolutely nothing and I read, instead of instructions that said, perform observable properties test, I would go, it's green. Done. Is that good enough? Absolutely not. Okay, what else should I make an observation about if I'm doing an observable properties test? Color is certainly important. What else should I look for? What are some other things I can get by being in proximity, close proximity to that sample? What else can I get? I can get color, I can get smell, yeah, okay? Should you probably tell them how to get that? Okay, we do this, right? We waft it. I would do that with the actual sample at the front. Don't do that over your depression plate when it's got 6 samples in it. You do this, you're gonna smell them all. Okay, I would waft the original sample at the front. Okay, details to be included there. Okay, use the sample at the front. Waft it. Send the guy who's not sick. Okay, don't send the guy who's hard of smelling. The guy who had COVID and lost his sense of smell and hasn't smelled the thing since. Don't send that guy. Okay, be explicit. Okay, other things that might be in the observable properties, maybe state. Right, we said that state could be a way to identify whether it's ionic or molecular, or at least give you a hint. Okay. If it's a solid, can we talk about what kind of solid it is? Like if it's, soft or hard or crystalline or waxy, or like maybe it's like gooey or whatever. Can we talk about its nature as an observable property? Okay, you put in your thing. This is what you should look for and this is what you should record. So that person can put a whole bunch of stuff in the observable properties part. Whatever you think might be helpful in identifying something. Okay, when I described that other compound a minute ago, okay, I said all of these things, all right? I said substance E was a blue crystalline solid with no odor, who dissolved easily in water, okay, whose solution conducted electricity, and whose pH was 6. Okay, so in that description, in those observations, 3 observable properties were important to me when I recorded them. There was no smell, it was blue, and it was a crystalline solid. Actually, that's 4 things. Okay? Solid and crystalline are 2 separate observations. Okay? All right. After you do the observable properties test, okay, because you have to do it first, you're going to add water to the substance. You're going to perform the solubility test. Okay? In the solubility test, should you tell them all the things they need to A, do, and B, record? Okay. When you're doing this test, what should you do? Do you just add water and wait? Okay, you think about it. Okay, how would you do that test? And remember that this instrument is part of that test. For those of you watching the recording who can't see me, I'm holding a thermometer. Okay? You're also going to have that glass stirring rod. Maybe it has an important function during this test. Okay? Maybe you should tell them how long you think they should use that stirring rod and the thermometer for. Okay? Maybe there's a good amount of time that should be included in that. By the way, don't make it 5 minutes. We don't have that kind of time. Okay? Right? Should you, as something to record, should you record maybe how well it dissolves or how much of it dissolves, if maybe all of it doesn't? Okay, maybe if there's a color change that happens to the water, that might be important. Okay, think of all the little things you might want somebody to record when they're doing that test. something else to include in that test. What should you do with the thermometer and the stirring rod after the test?
Clean it.
Yeah, you should rinse it with distilled water. We have the wash bottles full of those. Okay, those are gonna come in really handy, you're gonna use them a lot. Okay, you're gonna rinse off everything that goes in that sample after you do it. Right? Otherwise, you could bring sample A into sample B, and then you would contaminate it. That would be bad. All right, once we do the solubility test, then we do the aqueous conductivity test. Okay, the solution is already made, okay, in the solubility test, so we already have it. Now we're going to test whether it conducts electricity. This is a pretty simple test. What do I have to record in this test? I push the button, I stick this thing in, what do I record? The number on the face. Okay? 1 means non-conductive, actually, basically 1 to 4 means non-conductive, okay? 7 and above means really conductive. Okay, and you can say, you know, this was a 10, it really conducted. This was a 7, it conducted fairly well. You shouldn't get any in the middle. Okay, you're either going to get non-conductive, 4 or below, or you're going to get conductive, 7 or above. Okay, if 4, 5, or 6 light up on here, something went wrong. Okay, what should you do with this after the test? Clean it. Rinse it with. Is that an important detail? Yeah, this person, you know, if you don't say rinse it from the wash bottle containing distilled water, they're gonna put it in the sink. And they're gonna get ions from the tap water all over it. And then they're gonna mess up every sample they do after that. Little details, okay? Super important, but little details. Okay, once I perform the conductivity test, then I need this little vial of Hydreon paper. What does it test? pH. Okay, is it a pretty simple test to run as well? But there's little important details, okay? Like, take a strip off and do what with it? Rip it in half, okay? One of these can test 2, okay? One little strip can test 2. So tear it in half, okay? Put it in the solution and compare to the color chart and record the pH, okay? You put it in your words, but that's the pH test. It's pretty straightforward. What do you do with the paper after? Just throw it in the garbage. Don't put it down the sink. Put it in the garbage. Okay? Should you just leave it on the table? Because I see people do this. They're like testing them and then they're leaving the pieces of paper on the table. Okay? They're going to stick to the table, especially the ones that are in a strong acid or a strong base. You're going to put that strong acid or strong base on the table and it can, you know, start eating the table. Okay? When you get in there, you'll see a few spots where people spilled stuff that was bad. Okay? It's like one table that's got like a crater in it. Okay? Okay. Have we just performed all the tests? Observable properties, solubility, aqueous conductivity, and pH. Okay, all the tests are run. What do I do now? Clean up. Okay, here's how you clean up. There's a couple of little details. Okay, you're going to have your depression plate, and it's going to be full of stuff. And some of that stuff is corrosive, and some of that stuff is toxic, and it should not go down the sink. Okay? The only thing that should go down the sink is when you rinse off the stuff with distilled water. That can go down the sink. Everything else needs to go into the fume hood. In the fume hood is what we call the disgust bucket. You'll see it. You'll know it exactly when you see it. Okay? It's a bucket, a pail, okay? A 3-gallon pail full of disgusting stuff. Okay? You are simply going to take your wash bottle and spray off your depression plate, so everything goes in the disgust bucket. Okay? It doesn't have to be spotless, you just have to get any chunks out. Okay? The rest you can clean at your sink. Okay? Once it's clean and dry, where should you put it? back where you got it. The cart at the front. My Career 2 class is gonna need it, so that's where it needs to go. Okay, plus I don't have time in my life to clean up all your dirty dishes. At this point, are you still wearing safety goggles? Okay, think about what you should do with those. See, there's all these little details. If you don't tell them to take the goggles off and put them away, they're gonna walk away with them, and then we're not gonna have safety goggles. You laugh, it's happened. All right, so here's what you need to do with the remainder of class. Put some detail in there for your procedure, okay? Put some meat and detail into your hypothesis, your variables, all of that stuff, okay? That will complete the pre-lab part of this, okay? Then we'll be ready for Thursday to go into the lab and get our data, okay? On Thursday, after we get our data, I will talk about the analysis. Okay, not even gonna talk about that right now. Okay, we got stuff to do before we get to that point, right? So you've got another 18 minutes, okay, to work on this pre-lab part. Give it some spit and polish, okay? Yeah. All right. If you want to, you can, talk to a person who's gonna be in your group and say, this is what I've got, what have you got? That's okay, as long as you're not writing down exactly the same thing, okay?